Hi children, welcome back to our channel. In this video we are going to discuss about the one of the most important for 8 marks question in the point of view of public examinations. Most important question. That's why you have to watch the video very carefully up to last, and without any skip you have to watch the video. And children, we are going to discuss about the today's topic is derivation of time period of a simple pendulum. Derivation of a time period of a simple pendulum. So the oscillations made by the simple pendulum is nothing but simple harmonic motion. Now we have to prove that the oscillations made by the simple pendulum is harmonic, and we have to derive the expression for time period of a simple pendulum, and we have to define the seconds pendulum. First thing is, what is mean by a simple pendulum? Simple pendulum is nothing but a point mass is suspended from a rigid support with the help of inextensible and flexible string or a thread. So here it is the point mass that should be suspended from a rigid support with help of inextensible and flexible string and massless string, and now it is the point mass like a bob, and it is point of suspension, and this is the center of gravity, and the distance from point of suspension to the center of gravity, this point is what? Center of gravity of the bob, and this is what? Point of suspension. The distance between these two, what we call length. What it is? Length of the pendulum. Clear? It is simply about a simple pendulum. Children, now it is at the extreme position, it is at the equilibrium position. Now this bob is at rest position, and that should be here equilibrium position. And if you can push like this, if you can apply some force like this, then it will execute the simple harmonic oscillation. When the bob is at rest, then that is said to be in equilibrium position. If you can give a little push, and if you are applying some little bit force, then it will execute the oscillations. So here I am showing now, here this is the bob, and we pushed it, and that should be goes to the extreme position, and again that should be make some oscillations. So like this, it will execute the oscillations like this. At every time it can crosses the mean position. So this one is mean position, and this one is here extreme position. What is that? Extreme position, and this is also extreme position. When it will make some oscillations at every time, that should be crosses the mean position. Clear, children? So in the condition of simple harmonic motion, what is that? The motion should be oscillatory. So that's why here, what is that? The bob will make some oscillations like this. So the motion, what it can be repeated, that is the periodic motion. And when the bob is moving like to and fro motion, this simple pendulum consists of a bob, and the bob will execute the oscillations, and that oscillation can consist of to and fro motion. That's why here what you have to say, the bob consists of, first thing is to and fro motion. During the oscillations, at every time the bob will crosses the mean position, and in this case also we have to prove that A is proportional to minus x. Acceleration is directly proportional to the displacement, but it is in opposite direction. So these three conditions will be applicable for any simple harmonic motion. First thing is what? A body must be consist of to and fro motion, and second thing is what? As every time during the oscillation it should be crosses the mean position, and third one is what, children? acceleration is directly proportional to the displacement and both are in opposite direction, and the acceleration is towards the mean position. These three conditions must be satisfied by the any body, then the body is said to be in SHM, simple harmonic motion. Okay children, now coming to the point, derivation of time period of a simple pendulum. What is mean by time period? What is mean by a time period? Time taken by the pendulum or simple pendulum to complete one oscillation is called time period. Time period. For example, here just imagine now it is A, B, C. Here when the bob is at A, that should be going to the motion like this, reaches the C, and again that is coming to the A. It is started at A and reaches the C, and again it is coming to the A. So then what you have to say, one oscillation is completed. It is started from A, goes to the C, and again coming to the A. Then what you have to say, one oscillation is completed. The time taken by the pendulum to complete one oscillation is called time period. So now for this time period we have to derive the equation. Okay children, simply we are taken a simple pendulum that should be having some length L, and that should be suspended like this, and if you can give a little push, it will execute the simple harmonic oscillations. Then here when it is during the oscillations, it is at this extreme position, then theta is the angular displacement. Now it is the mean position. When it is goes to the extreme position, then it will make some angular displacement, how much? Theta. So when it is at extreme position, here this theta should be divided into its components. Simply here I am going to say there is some weight, because bob mass is what? M, and that should be in air. That's why automatically some weight will be there. That weight is what? Mg. Now this weight of the bob should be divided into two components. One should be like this, mg sin theta, and next thing is here mg cos theta. Clear children? So now it is the angle theta. Simply you have to remember that when the bob reaches the extreme position, at that point the weight can be resolved into two components. One is mg cos theta, that is showing here vertically downwards, and mg sin theta is along the horizontal direction. So first thing is what? Weight is divided into two components. One is what? Mg cos theta is vertical component, and mg sin theta is horizontal component. Clear? And now children, at the extreme position, the weight is divided into two components. Mg cos theta is vertically downwards and mg sin theta is in horizontal direction. So that is the first you have to remember. And now children, at equilibrium, there is one condition. It is children, at equilibrium, here it is a rope or a thread, that's why tension is acting in upward. At equilibrium children, the tension is balanced by the mg cos theta. Clear? And similarly here at the extreme position, there is some restoring force. Here what is the restoring force? What is mean by restoring force? You have to know the energy what it is stored in a body itself, that is what we call restoring force. Children, you have to observe one thing here. When the bob is at the mean position, we are giving the push, and when due to the applied force that is going to the extreme position, at that point its velocity is 0, but velocity is 0, that is coming again back to the mean position. So to understand that, simply I will give one example. We are throwing a stone into the air. Due to the applied force, that will be going into the upward direction. After reaching some maximum height, there the velocity is 0. After that, from that point only it comes down. Why? Because of under the influence of gravitational force. In the same manner, due to the applied force, the bob is going to the extreme position. Clear? So after that, while reaching the extreme position, automatically its velocity becomes 0. But again that should be coming to the mean position. That is because of restoring force. What is the children? Restoring force. Here the restoring force will be provided to the bob only because of gravitational force. Gravitational force. That's why here I am going to write here restoring force. Restoring force. That is what, children? F is equals to minus mg sine theta. This is equation number 2, children. After that, here you have to remember the children, when the angle is very small, when the angular displacement is very small, we can write when theta is very small, then what you have to write, children? F is equals to minus mg into theta. That means simply we will take, when theta is small, we will write sine theta is equals to theta. So F is equals to minus m into g into theta. That is equation number 3. So children, after that you have to observe the diagram. This is what? Pendulum length, and it is the extreme position. And now here simply you have to remember that this is what? X. X is what? Nothing but displacement. What is that? Displacement. Then here what are, children? This is theta. Theta means what? Angular displacement. So already we know that angle is equals to arc by radius. Arc by radius. Angle is equals to what, right? Arc by radius. Here what is the arc? X. And what is the radius? L. If you can consider a circle, L is the radius. If the bob will moves in a circular path, then L becomes the radius. That's why what you write? Theta is equals to X by L. Got my point, children? Here it is the simple pendulum length L. If you can construct, if the simple pendulum goes like this, a circular motion, then that particular length should be taken as the radius. And already, children, from this figure, this is the extreme position and this is the mean position, and the bob is moving from extreme position to the mean position. Then X is what here? Nothing but displacement. So when we construct the circle, now this X becomes as the arc. That's why simply from figure what you have to write? Angle is equals to arc by radius and theta is equals to X by L. So that's why here I am going to write there F is equals to, next one is what? F is equals to minus mg into X by L, arc by radius, since theta is equals to X by L. Clear, children? So F is equals to minus m into g into X by L. Now this is the equation number 1. And children, here d square x by dt square, that gives the acceleration. Rate of change of displacement is what we call velocity. Like that, d square x by dt square is what? Acceleration. So here we will write d square, let d square x by dt square is the acceleration. What is the, children? Acceleration. That's why here, according to Newton's second law, what we write? F is equals to ma. What is that? F is equals to ma. Then what you write? F is equals to m into, here a means what? D square x by d square. Clear? Now equation number 5. Children, very simple. We are taking the d square x by dt square is the acceleration. Then already we know that F is equals to ma formula according to Newton's second law. Then what to write? We have to write it instead of a, what you have to write? D square x by dt square. Then F is equals to m into d square x by dt square. This is the equation number 5. Here both are represents the force. That's why we have to equate them from 4 and 5. From 4 and 5. Then what you have to write? M into d square x by dt square is equals to, we have to equate them. M into d square x by dt square is equals to what? Minus mg into x by L. Here m cancel, m cancel. Then what do you get? D square x by dt square, d square x by dt square is equals to minus g into or g by L into x. D square x by dt square is equals to minus g by L into x. So children, now we have to compare this equation with the general equation. What is general equation? D square x by dt square is equals to minus omega square into x. We have to compare these two. So children, we are getting this equation is what? By equating these two, what we get? This one, d square x by dt square is equals to minus g by L into x. Children, clear? After that, here we have one general equation for simple harmonic motion is that, what is that? D square x by dt square. Then equation is equals, that is equals to minus omega square x. Now we have to compare these two. When we are comparing these two, what to get, children? Minus omega square is equals to minus g by L. That means what? Omega square is equals to what? G by L. Omega square is equals to G by L, or omega is equals to under root of G by L. Omega is equals to under root of G by L. Okay children, already we know that for time period we have general formula is there, that is what? T is equals to 2 pi by omega. T is equals to 2 pi by omega. Already what is the omega value? Here as T is equals to 2 pi by omega by under of G by L. Then what do you get, children? T is equals to 2 pi into under root of L by G. So this is the expression for time period of a simple pendulum. Clear children? T is equals to 2 pi into under root of L by G. So children, this is the expression for time period of a simple pendulum. From that equation, we have to conclude that time period is independent of only length of the pendulum. Length of the pendulum. That means there is some directly proportionality between these two. What is that? T is proportional to root L. And thus you also depend upon the acceleration due to gravity. Acceleration due to gravity. If we are doing the same experiment of simple pendulum at one place, at only one place, then it is not depend upon the G value, because it is constant. Then what you write? T is proportional to root L. Clear? This is the expression for time period of a simple pendulum. From that, what you have to do, children? Here T value depend upon the L and G only. When we are doing the same thing in a lab, then G value does not change. Then what you have to do? T is proportional to root L. When the value of G will be changes, what is the G? Acceleration due to gravity. Generally its value is taken as 9.8 meter per second square. When we can doing the same experiment on Earth, on Moon, on other some planet, then only G value is changes. We are doing the same experiment in laboratory and we are doing the same thing on a cliff, then G value is changes, then time period also changes. Okay children, from this formula we can conclude that the time period of simple pendulum is depends upon the length and acceleration due to gravity. And next thing is what, children, you have to remember that the time period of the simple pendulum is not depend upon the acceleration, not depend upon the amplitude. It does not depend upon the amplitude. Clear? time period of a simple pendulum is not dependent upon amplitude. When the amplitude is very small, it is independent of amplitude. When we are provided the amplitude is very small, then time period is independent of amplitude. So children, this is about the derivation. And next thing children, what is mean by seconds pendulum? What is mean by seconds pendulum? The time period of a simple pendulum is 2 seconds. The time period of a simple pendulum is 2 seconds. Then that pendulum is called seconds pendulum. Just now what I told you, for example, here we will take, this is another position, extreme position. From here to here it is one half of the oscillation, and here to here is one oscillation. For example, here if I want to go like this, these two are the now extreme position. These two are the extreme positions. I am saying now A, B, C. A to C is half oscillation completed. C to A is half oscillation completed. That means if the oscillation starts from A and that should be goes to the C and again coming to the A, then one oscillation is completed. If any simple pendulum will take 2 seconds to complete the one oscillation, then it is called a seconds pendulum. And children, seconds pendulum length is almost all 1 meter or 100 centimeters. Okay children, see once again, very important question, you have to remember very carefully. Children, what is a simple pendulum? Simple pendulum is nothing but a point mass is suspended from a rigid support with the help of the inextensible and flexible and massless thread or a string like this. Now what you have to find out children, we want to find out the time period of a simple pendulum. For that, for example, we are taking, this is the bob and we are giving a little push, then it will execute the simple harmonic oscillations. So children, it is a having to and fro motion, and in this case what you have to say, it is like this, d square x into dt square is equals to minus g by l into x. Here it is quite similar to the simple harmonic equation. That's why the oscillation made by the simple pendulum is simple harmonic. Manaki d square x by dt square is equals to minus omega square into x ఫార్ములా ఉంది కాబట్టి ఇవి రెండు సేమే ఉన్నాయి కాబట్టి మనం ఆల్మోస్ట్ అలా ఏమనుకుంటున్నామంటే ఇప్పుడు ఆసిలేషన్స్ చేసే సింపుల్ పెండమ్ అనేది సింపుల్ హార్మోనిక్ మోషన్ని కలిగి ఉందని చెప్తాము. ఓకేనా చిల్డ్రన్, నౌ కమింగ్ టు ద పాయింట్, when we are pushing the bob, it will execute the simple harmonic oscillations. When the bob is at the extreme position, here we can observe that theta is there. Theta is what children? Angular displacement. When it is goes to the extreme position, there the weight should be divided into two components. Clear? That is what weight is divided into two components. Mg cos theta is vertically downwards and mg sin theta is horizontal. So I already told you what's that, due to applied force the bob is moving from mean to the extreme position, but again the bob is coming from extreme position to the mean position because of what? Restoring force. That restoring force is provided to the bob only because of gravitational force. That's why children, here we are going to write at the extreme position we are having mg sin theta and mg cos theta. Mg cos theta is vertically downwards and mg sin theta is horizontal. Children, when the bob is at extreme position like that, and if you can take the equilibrium condition, then T is equals to mg cos theta. Here T is what children? Tension provided in the string that should be acting vertically upward. Then what you have to write? T is equals to mg cos theta. Just now only told you what is that, due to restoring force it is coming from extreme to the mean. That's why restoring force is what? F is equals to minus mg sin theta. And when the angle is very small, that means angular displacement is very small. When angular displacement is very small, what you have to write? F is equals to minus mg into theta. Sin theta is equals to theta. Then after what you have to write? F is equals to minus mg into theta value is what? X by L. Then F is equals to minus mg into x by L. So after that, here what is theta value? X by L. Just now I already told you what's that. Theta is equals to angle is equals to what? Arc by radius. Here arc is what? X. Radius is what? L. That's why F is equals to minus mg into x by L. So children, we will consider d square x by dt square is the acceleration. Then according to the second law, what write? F is equals to ma. Then F is equals to m into d square x by dt square we are substituted. After that we have to compare these two equations. We are equating these two, then what we get? D square x by dt square is equals to g by l into x. And this is quite similar to the general equation like d square x by dt square is equals to minus omega square into x. Then minus omega square is equals to what? Minus g by l. We are comparing these two. Then what you get? Omega square is equals to g by l and omega is equals to under of g by l. And after that, children, already we know that time period is what? T is equals to 2 pi by omega. Then we have to substitute the omega value. Then what you get? T is equals to 2 pi into under root of L by G. From that, what you have to say? T is proportional to root L and T is proportional to the 1 by root G. That means what? T depend upon the L and G and it is independent of amplitude. And next thing is what, children? We have to find out the length of the 2 marks 8 marks question lo 6 marks ఇంతవరకు వస్తే 2 marks ఏముంటుందంటే we have to find out the length of the simple pendulum, seconds pendulum. T is equals to 2 pi into under of L by G. So what do you write? T square is equals to 4 pi square into L by G. So children, what I told you for seconds pendulum, for second pendulum T is equals to what? How much time? 2 seconds. Then you have to substitute here. 2 square is equals to 4 pi square into L by G. Then what you get? 4 is equals to 4 pi square into L by G, children. 4 cancel. Then what you get? L is equals to G by pi square. L is equals to 9.9 by 3.14 whole square. Then what you get? Almost this is 0.98. Then what you get? L is equals to 1 meter or 100 centimeters. So children, this is a very important question. If you have any doubts, just go the video just back and watch continuously. So you have to watch the video repeatedly, then automatically you will find everything is very clear. After watching it, like, share, comment the video and subscribe my channel to get all notifications. We will meet in the next video with some other interesting topic. Bye. Take care, children.